Okay, hello South Carlton. Today we're going to be doing a new video lesson about factoring trinomials. Up until now, we've been basically working with binomials and trinomials. And those of you who recall from our very first video lesson that I did, we recall that binomials, okay, they always have two items, okay? So they're always going to have just two things being added or subtracted from each other. Some things like 2x plus 3 or x minus 1 or 5x plus 5. These are all things that have two things being added or subtracted by each other. 1, 2, 1 and 2, and 1 and 2, okay? The other thing that we talked about also is trinomials, and these are the things that we have to distinguish between binomials and trinomials, okay? And just like binomials, okay, they're just a string of things being added or subtracted from each other. The only difference is that there's three items, so there could be three unlike terms, like 3x plus 2x plus 1, or 2x squared minus 1 plus 5x. It doesn't really matter too much what the items are, as long as you can see three individual items, okay? So in all three of these expressions, we have three things being added and subtracted from each other, okay? And that's why they are called trinomials. So trinomials have three things added, subtracted, okay? You have three things that you add and subtract, okay? Conversely, binomials always have two things, add and subtract. Okay, so in previous lessons, you have learned that if we have two binomials being multiplied by each other, we know by now that we can use a table. This was from one of our lessons a few weeks ago, so I encourage you to go back to the expanding binomials FOIL worksheet if you have not done it yet. Okay, so if you remember, the way we solve by doing this expression over here is that we write the x here, okay, so the 2x here and the plus 3 here, and then we write the second bracket in the columns and the first bracket in the row, okay, minus 1, so x minus 1 goes here, 2x plus 3, it goes up top, and then we just multiply, okay, so 2x squared plus 3x, because 3 times x is 3x, minus 1 times 2x, that's minus 2x. Negative 1 times plus 3, that is minus 3. And then the final answer would be just the product of everything that we have over here. So we just copy everything down, 2x squared plus 3x minus 2x minus 3, okay? And don't forget that we also had to collect the like terms in the middle, pardon me. Okay, and once we do that, okay, plus 3x minus 2x, that's just a singular x right here, and voila. Okay, so this was from one of our few lessons a few weeks ago, pardon me. Right, now let's say that, let's say the reverse, okay? Let's say if we want to revert everything we just did here. What if I gave you a trinomial, something that we have here, because it has three terms, because there's 1, 2, and 3 things being added or subtracted each other, and I wanted to revert back into that form that had two brackets inside with a few expressions. How on earth do we do that? That's going to be what we're going to be doing today. Okay, so over here I have a trinomial. I have three items, 1, 2, 3, and I want to put it back into something that has a bracket with only binomials inside. So I only want two things inside of this bracket. I only want two things inside of this bracket. So how in the world do we do that? Well, it's actually quite easier, and depends on, figuring out what pairs of numbers will work with what combinations, okay? What you want to do is that you want to take the last number, and you want to take the middle number with their integers, so their signs, positive and negative signs, and you want to figure out how you can multiply to the last number and add to the middle number, okay? So what I like to do is, yes, I like to write that out, okay? We want a pair of numbers that would multiply to 2, and it would also add to 3, okay? So you can think of it as like figuring out different kinds of combinations of numbers that would work for both cases, okay? So we want one pair of numbers that would multiply to 2 and also add to 3. So these two numbers have to be the same, and these two numbers have to be the same. For example, you can say that 1 and 2 would work, right? 1 and 2, 1 times 2 is 2, 1 plus 2 is 3, so that is a-okay. What you cannot do is the following, okay? You cannot say, oh, well, there's also, what you can do is that you can do, let's say 0 plus 3. That's also equal to 3, right? But does 0 times 3 equal to 2? Does 0 times 3 equal to 2? It doesn't quite work, okay? So this works here, but it does not work up here, all right? So we want to maintain the pair of numbers that are consistent, okay? So it has to be the same for both. Okay, that pair of numbers, and the only pair that I can think of is currently 1 and 2. 1 and 2. All right, so now what you do is that you simply build up the brackets, okay, and you put an x in each, okay? You put one x in each, and now you basically, because this is a positive 1 and a positive 2, a positive 1 and a positive 2, you put that as a plus sign, okay? So it's being added by 1, being added by 2, and then you're done. And then you can put an equal sign at the very end. This is going to be equal to these two binomials, because again, they have two terms, 1 and 2, 1 and 2, that are being multiplied to each other. Okay, we'll do a few more examples. Okay, so the next one here is interesting, because let's again follow the same tactic of figuring out two numbers that multiply to the last one and add to the second one, okay, the second number. Again, be very careful because it has a negative sign, okay? This negative sign goes with that 4, okay? So we want two pairs of numbers, okay, that would multiply to positive 4, and that same two pair of numbers has to add up, okay, has to add to negative 4, okay? So we can think of the numbers right now, okay, and those numbers, what times a number would equal to 4? Well, we can use 2 and 2, okay? So, oopsies, 2 and 2, these two numbers, they both multiply to 4. But 2 plus 2, does that give us minus 4? That doesn't quite work. What we notice is that because of the fact there's a negative sign, why don't we try putting negative signs here, okay? And if we put negative signs in this pair, we also need to put negative signs in the top pair, okay? Always remember the pair of numbers that you use must be the same, okay? And we can do the calculations again. Negative 2 times negative 2, that is indeed negative 4. Negative 2 plus negative 2, that indeed is also negative 4. So in both cases, they check out, okay? And the numbers in both cases are the same. So what we can do is that, again, what we're going to do for the final answer is that we're going to put double brackets. We're going to put a singular x in each, one here, and we're going to copy down these numbers, minus 2, minus 2. So our final answer, if we convert this trinomial into binomials, it's going to be x minus 2, x minus 2. What people like to do is that because of the fact that these two are exactly the same, we could simply rewrite this as x minus 2 to the power of 2, because it's just the same thing being multiplied by itself, similar to how 2 times 2 is just 2 to the power of 2, or 3 times 3 is 3 to the power of 2, because it's just multiplied by itself twice, okay? Alright, one final example, slightly bigger numbers this time, but again, it's the same old tactic. We want to find two numbers that multiply to negative 27 and add to positive 6, okay? So multiply to negative 27. Be very careful of that negative sign, alright? Make sure to not forget. And we have to make it add to 6, okay? So what I always like to do is I try to think about pairs of numbers that would multiply to 27. So what do we have? We have 1 and 27. That multiplies to 27. Let's ignore the negative sign for now. 2. Does 2 multiply anything into 27? It doesn't quite think so, right? I don't think 2 would work. 3. How about 3? 3 multiplied by 9 is equal to 27, okay? And we can keep on going, okay? I don't think any other numbers work aside from these two pairs. So let's think of these two pairs of numbers, okay? Which pairs of numbers, okay? So either this first pair over here or the second pair could potentially make a 6 from. Can we make a 6 from 1 and 27? I don't think so. The difference is too big. Can we make a 6 from 9 and 3? Yes, we can. What we can do is that we can take the 9 and we add a negative 3 to that, okay? And we also know that 9 times a negative 3 is going to be negative 27, okay? And voila, we have our answer. We can again put double brackets with one singular x in there. We're going to have a positive 9, so we're going to add a 9 and we're going to subtract the 3, okay? And so our final answer in binomial form is x plus 9, x plus 3, okay? X minus 3. All right, so what we are doing right now is called factoring, okay? This whole technique of taking our trinomials, which have 3 items in them, and putting them in brackets with only 2 items in them is very, very useful for what we're about to do later. Because right now we want to distinguish between the factored form, okay? So this is what we call the factored form, okay? With the 2 items in every single bracket, okay? And over here we call it the expanded form or standard form, okay? Expanded / standard form, okay? And these always have 3 items without any brackets at all, okay? All right.